We're going to look at recycling PLA, 3D printed watch bands, and cheaper DD powder. This is 3D Printing News Unpeeled, and I'm Joris Peels. This is brought to you by 3dprint.com. So, first thing is Filamentive, the UK-based filament supplier, is going to recycle PLA. So PLA is a really incredibly popular 3D printing material. It's made from plants, and everybody just assumes that it's wonderful for the environment as a result. A lot of people are finding out, of course, that's not true. It takes about 7 liters of water to make 1 kilo of PLA. PLA is made from corn, but that's a foodstuff material. So it's not made from corn waste or waste from the corn husks, for example, or something like that. No, it's made from the actual corn itself. So if you would switch to PLA for all of our plastic in the whole world, food prices might rise. So that's not good for anyone. And it's very difficult to end of life dispose of PLA. So, but so far, many more people know this, but there isn't really a solution. Now, PLA or now Filamentive has come up with a solution for its customers. The idea is that if you want your customer that spends about 500 pounds, UK pounds of money with them, they will send you a box, which is good for 45 liters of recycling capacity, and you can keep that box. And then once it's full, you send it back to them. Now that will then go to 3D Printing Waste, 3DPW, which is a company that will then recycle it either into injection molding pellets, some kind of new product, or other kind of new application. So I think that's wonderful. I think 500 pounds of 3D printing material is, of course, a lot of 3D printing material. But I think if you're like a university or something, or a large company, this would be a really great thing to do, to really know that PLA is going to be used as something useful at the end of the day, not just end up in the trash or end up in a plastics recycling facility that's not really set up to handle, which is a really very niche type of product for them. So I think, I want more and more of this. Many more people are working at this. Materialize is working on this, other people, and I want more and more of this. Think about all the powder bed fusion powder, the polymer powder, the PA12, PA11 we throw away. You could easily turn that into filament, and you could still use it. You could still use a lot of really valuable scraps and parts of filament, and also the models we reject and we don't want anymore. We could really make filament out of it, or other types of materials to keep reusing it. So. And then we can really be a much more environmentally friendly application. So I think this is great, and I think we need more of that. We need more applications like that. More people are becoming greener. We're seeing better spools nowadays. We're seeing kind of more cardboard, other types of spools. We're doing stuff that's more environmentally friendly across the board, but we need to do a lot more, because we always have the feeling that, oh yeah, we're more environmentally friendly than injection molding. So we don't have to do anything, or we can't improve ourselves. So I think we can. And this is a wonderful thing. Another thing, which is also an environmental thing, by the way, is EnerAM. That's a UK project consisting of Atomizing Systems Limited, Laser Additive Solutions, Nuclear Advanced Manufacturing Research Center, Hybrid Technologies, and Brunel University. Now, that consortium of companies and research institutes has gotten £1 million to investigate the more energy-friendly manufacturing of DD powders. So they're kind of a niche thing, really, but all the powder that is manufactured for powder bed fusion or directed energy deposition type of processes. In the case of powder bed fusion, needs to have really very stringent kind of quality control, very stringent kind of dimensions and morphology and stuff like that. And for DD, it's much kind of like more relaxed. But generally, these processes, the trying prep or the other kind of processes that go into this, the atomization processes that turns bar stock into this really fine powder, are really energy intensive. So if we want to reduce the energy intensity going into the final product, if we want to make the final metal product more sustainable, we have to do something about this. So this is a really great project. They're getting £1 million. Sounds a lot of money. It's probably not a lot of money to do what they want to do, but they're starting with a relatively easy part of this challenge with DD powders, which are much easier, which are much less constrained than the powder bed fusion powders. They help to do a fifth less energy usage in the powder, which would be great. It would also mean for a lower cost powder, but also lower cost for the planet. So that's another really good piece of news and a really useful project. And I'm curious to see how far they'll get for $1 million, but the people themselves are bringing money. The partners are bringing money as well, so an extra couple $100,000. So that should be nice as well. And yeah, we'll see what that ends up being. The next news is, well, it's from Watches and Wonders. It's the premier now, I think, watch event in the world in Geneva. and that's for the ECAL, ECAL, or the University of Art and Design at Lausanne. They have a program which is Master of Advanced Studies in Design for Luxury and Craftsmanship. And that's focused, as you may imagine, because they're in Lausanne, that's very much focused on watchmaking and jewelry making, and with a fine art of watchmaking, as I practice in Geneva and there beyond. And what they did is they partnered with Alloyd, which is a UK company, which makes materials and does services and consulting, all that kind of stuff. And they developed 5 watch bands. Now, I think, first off, this is a beautiful idea. What they did is they allowed all their students to design for powder fusion, which gave them a little bit of a crash course in designing for powder fusion. They then chose the 5 best designs, and then they printed them and showcased them. This, if you're studying kind of some watchmaking kind of craft, hey, having a kind of little your name on something at Watch and Wonders is an absolutely fantastic career opportunity. So I think it's a wonderful class project. It's nice for Alloy. They get to have some really nice things to showcase to people, and they get to work on in the luxury industry. And we know that luxury industry is growing very, very quickly, and 3D printing, that segment is growing very quickly. So it's a great move for Alloy as well. And I think it makes people stand up and take notice of who these ECAL guys are as well. Great project. More universities need to do more stuff like this, more design schools. And some of the watch bands are, well, they're pretty darn dramatic. I'll tell you that much. We've got 2 in front of us right now. And they really show that, like, on the watch, there's a lot of patents actually on the watch casing and other parts. There's people working on certain watch components, certain components of the bezel, the watch itself. And we've seen in polymer from Panerai and in other metals from several different companies, we've seen them work on the watches themselves. Now, the tolerances and the needs generally of the watch industry are like incredible, really. So even though a lot of large watch groups use additive manufacturing to a certain extent, they're very, very picky about the machining, and they use lots of different processes that maybe can do things in tolerance and size, and part size especially, that we cannot do. And so on the one hand, that's a limitation of our technology, and it's also kind of like a limitation of how far we can go in this luxury business. And I think watch bands are absolutely fantastic kind of application. Now, I don't know how wearable these things are. I don't know how comfortable these would be. Like the one on the left, the purplish one, that seems kind of completely crazy. But if that interlocking mechanism actually does interlock like normal lugs do, it just looks dramatic. That actually might be a really very comfortable type of watch band. So I think this is fantastic. And I think fantastic marketing thing, and I think people should do more of this. The other thing is, the one thing that really surprised me, what I didn't see amongst these ones, I didn't see all of them, but is chainmail. To me, if we wanted to do this, then a chainmail type design. Maybe they were only going to do certain powder bed fusion. They only did titanium. Maybe they weren't able to do this, but with several other technologies, several other approaches, you can do chainmail type of designs, and that would really end up having a really complex, really exciting, potentially, and also super comfortable watch band. So I'm surprised actually I didn't see that. But maybe they're tied to a process or something that I wanted to decomplicate their lives. Anyway, that's that. I think it's a great example. My name is Joris Peels. This is brought to you by 3dprint.com, and it's called 3D Printing News Unpeeled.